Okay, guys, let's start. Thanks for joining us today. I will do a quick introduction. So my name is Anton Malinin. I'm a staff UI developer here in Grid Dynamics Poland, and welcome everyone to this series of this episode of Dynamic Talks. The Dynamic Talks is a series of meetup that happens in the United States and Central Europe. It's organized by Grid Dynamics. So we love to share our technical expertise on multiple topics, machine learning, artificial intelligence, UI, big data, and so on. And we are always open for the technical speakers. So guys, if you want to become a part of the next episode, please feel free to reach out to Grid Dynamics marketing team or to myself. We will do a send out after this session with the Tech Talk materials and the key contacts. One more thing, if you guys have questions during the talks, please raise your hand. There is a button for that. When the Tech Talk is over and there is time for questions, we will pass you the microphone. So let us not wait for the first Tech Talk long. So we have the first guest. It's a UI developer from Grid Dynamics Krakow, Alexey Gaynulin, and his talk, which is called The Practical Usage of Machine Learning for a Developer. Welcome on stage, Alexey.
Thanks, Anton. Hello, community. I'm going to share the screen and I will start. Okay. So, hello community once again. The title of my presentation is The Practice Usage of Machine Learning for a Developer. First of all, I would like to say that I am not a machine learning specialist at all. I am a software engineer. And in our profession, we have to study new technologies constantly. And we have to enhance our skills and so on to stay in our profession. And I'm sure that currently the most important challenge for us, for developers, is machine learning. But we don't need to be machine learning specialists. We as software engineers should at least understand the power of machine learning and when to use it, or at least understand when to delegate our routine tasks to a machine learning specialist. But what are machine learning tasks from a perspective of a software developer? So, as software developer, we should ask ourselves the following questions. The first question is, what kind of data do we have? There is some aspects of it, so we can have amount of data, quality of data, and so on and so on. But the common question that we as software engineers, not machine learning specialists, but as software engineers, we should ask ourselves, do we have enough data? So if we don't have enough data, or we need to make some efforts to collect this data and so on, we don't need to use machine learning. Once again, it is for machine learning, not for machine learning specialists, it is for software engineers. So if we have enough data, we don't need to make some efforts to collect that and so on. So we can ask ourselves the following question: what kind of task do we have? To answer this question, let's take a look to the machine learning categories. Briefly, we can see that machine learning categories, we have supervised learning, we have unsupervised learning, we also have reinforcement learning, but it doesn't matter within the scope of our presentation, our current presentation. Very rawly and briefly, we can divide machine learning categories into four main parts. So it is tasks of classification, tasks of regression, clustering tasks, and association tasks. So but don't be afraid of so many theory of machine learning. Today we will pay attention only for clustering, only for clusterization tasks. because it is the most simple way for demonstration purposes. So, there is a green zone. The following tasks, so following business tasks, if we have enough data, we need to use machine learning. We need to use to apply machine learning approach. So for the following tasks as clustering, data mapping, association, predictions or forecasting, or even just data visualization, feature selection. For example, we need to grab some text from a text, or for recommendation systems, but not from all recommendation systems, but for recommendation systems with multi-input cases. For example, if we have one input case for our recommendation systems, it will be much more easy. It will be much easier to apply coding approach, user behavior, and pattern recognition. For these tasks, we for sure need to use machine learning approach. Of course, we have a wide range of REST tasks for which we can use machine learning approach, but it depends, and it depends on our business task. It depends on our environment, on our technology, on our team, and so on, and many factors, because sometimes it is more cheaper to implement such tasks using coding approach, using some programming code libraries. For example, for image processing, we have very powerful libraries and so on, but it depends. So we are talking today only about green zone. And so once again, from a perspective of a software developer, software engineer, we should ask ourselves two questions. Do we have enough data? And what kind of task do we have? If we have kind of task from this green zone, for sure we need to use our machine learning or delegate our task for a machine learning specialist. This is very important to understand. As for me, I faced with such kind of tasks maybe twice a year. And for them, I try to use machine learning approach. And here in my presentation, I will provide an example of such task. For example, let's imagine that we have a project with geodata, with coordinates. For example, we have travel project and should render on a map hotels offers from different suppliers. We work with a wide range of suppliers which provide data. In our case, it is hotels offers. And different suppliers provide their data for the same cities along with other suppliers. So there are too many letters here. So let me show the picture that will explain everything that I was told. So we have two offers in our city. In my case, it is Italian city. We can see it here. So the first supplier provides an offer of Pescara city. The second supplier provides an offer of Montesilvano city. We can't understand the first supplier why he provides us the offer for Pescara city, because Pescara city, it is the closest big city to the offer coordinates. So we can understand suppliers, but we have what do we have? What do we need to do? We need the mapping of these two offers to the one city. As we see, we have these offers from one city. It is for sure it is Montesilvano city. But in our database, after integration with the supplier, we have the following data structure. We have ID of the offer, longitude, latitude, city ID, region ID, country ID, and title. As you can see, we have different title here. We can different city ID here for these two offers. Of course, we have different coordinates for them, but the main point that we have different cities for these offers that probably are in the same city as we see. So, okay, what's next? For example, let's imagine that in our project we have about 100,000 offers or even million offers. It is real situation, and we can have about a million offers, and we need, let's start from the end. For these offers, we can send a request via some geocoding API. For example, Google Geocode API to retrieve all the city data for a particular city by coordinates, latitude, longitude, and so on. So we can send it. It is quite easy. Yes, we just take some geocode API. We send request. We retrieve the response with ID, hash of the city, title of the city, coordinates of the city center, and the rest necessary data that we need. But in our case, we need to send a lot of requests. 1 million requests. Sorry. 1 million requests to obtain all the data of cities that we need for all our offers. And there are a lot of requests. What should we do? First of all, we should reduce the amount of requests so we can cluster our offers into cities. So the first task, it is unite offers into cities clusters. So okay, it is interesting business task, and from my perspective as a software engineer, I can ask myself the following questions. So, do I have enough data? Yes, I have enough data. I have longitude, latitude, and it is consistent data. Yes, this for sure. The answer is yes. The second question: what kind of task do we have? We have task of clusterization. As we studied it before previously, for sure we need to use machine learning approach here. Okay, so I determined to apply machine learning approach here, but I'm a software engineer. Let's go on. Let's cook it. So steps. What steps should I pass through to implement my solution? I have data in SQL. I need to export data from SQL. I need to prepare this data somehow. I need to apply a machine learning algorithm also somehow. And I need to export data back to SQL to work with this result, to work with this solution. So quite simple steps. It's not simple steps, but quite clear what we should to do. And the first step, export data from SQL. It's quite simple, also quite simple task. So we have the following data structure in our database. We have, once again, we have ID of the offer, coordinates of the offer, longitude, latitude. We have city ID, which were provided by suppliers. We have region ID, we have country ID, and so on. So let's export this data to CSV file. In my only one point, I should mention that in my example, I will export only offers for Italia. In my case, it is country ID of 18. And then you will see why. So we export data. It's quite easy. Yeah, just export data from our export data from our database. The second step, machine learning clustering, prepare data. Okay. So first of all, I would like to say that I will use Jupyter Notebook. Jupyter Notebook is a very powerful interactive tool for code execution. You can execute your code. You can see the results as soon as you execute this code. You can it provides different visualizations, powerful visualizations tool. So it's really very cool for such kind of tasks. And I will use Jupyter Notebook and Python. Jupyter Notebook and Python is a great team for such kind of task. I'm a not Python specialist also, but you don't need to be a Python specialist to work with this tool, with this instrument. You just need to understand the basic concept, the basic syntaxes of the language, loops, Turner operations, and so on. So let's go on. So what we are doing here, it's a Jupyter Notebook. First of all, we import our Python libraries, matplotlib for inline graphics, Seaborn for visualizations. Matplotlib we need only for apply these visualizations in Jupyter Notebook. And for visualizations itself, we need Seaborn library. Then we export pandas. It is a very powerful tool for work with data. We can aggregate data, join, so really group data, group big amount of data. So it is a very powerful tool, pandas library. Also, we import Escalon library. In this library, we have min-shift powerful algorithm for clusterization from this Escalon library. This tool fits our task because we want to cluster cities which are close to each other. So it's appropriate algorithm for our task. And nothing crucial, it's not rocket science, we just import data. Then we, as you can see, we import data import library, sorry, and we prepare data, we clean data. So what we are doing here, we read our CSV file, read our prepared CSV file. We do some preparations. We just replace dots with commas or vice versa. We do casts from integer to float and or vice versa. And now you can see that our result is in data frame df and data frame object df, and we can see that we have the same data structures we had in SQL. So we have ID of the offer, longitude, latitude, city ID, region ID, country ID. So nothing's changed actually. We just worked in working in Jupyter notebook. So let's go on. The third step, machine learning clustering apply algorithm. First of all, we need to clean our data frame and keep only significant columns. So as you can see, for our task, we drop the following columns. ID, we don't need offer ID for clustering cities for our algorithm. We don't need city ID because city ID is just a digit that we got from a supplier. We don't need region ID and country ID. We need only longitude and latitude of each offer. So we just drop this data. It's not also machine learning, I can say. And the all magic of machine learning happens here in these 3 lines of code, or even in these 2 lines of code. The first line of code, we configure our main shift algorithm. It is just the main shift algorithm that we imported before, and we configure our algorithm. Then we feed our data, our fitting data to this algorithm. So all the magic happens here. And then we just, in this third line, we just store the results that keeps in clustering data labels object. So we just add a new column target that will keep all the results of this clusterization. Only one point, that is it, really, that is it for machine learning. And only one point I should mention for this implementation, I should explain why do we use bandwidth of 0.02. As we use longitude and latitude, we consider to cluster cities within the distance of 1-2 kilometers. So it's quite a good solution. We consider that every offers that in this radius 1 and 2 kilometers one to each other, we will cluster them in one city. Of course, we have big cities like Milan, Rome in Italy, but it will be very easy, and it will be very easy to unite the cities then by our programming language. But 1 or 2 distance, it's very good solution for such configuration. And why do we need 0.02? Because length of in 1 meters of 1 degree of latitude is always 111, about 111 kilometers. For Europe, 1 degree of longitude from 70 to 100 kilometers. So this value of 0.02, according to this coordinate that we have, will hint our algorithm the access, the appropriate access for our clusterization. So that is all. Let's check the results. It is we still at the third step. So as we see, the cluster cities will be united by target field. The only difference and most important point is that we got 1 additional column, target. Offers with the same target represent the same city. As we can say, we have 5 such offers in one, at least we have 5 offers in the same cities here. Of course, we have more, but here we can see that there are cities that was united in one, clustered in one city. Also, let's describe some information. It's just meta information, nothing. We can see by df cluster describe function. It is a very powerful function also for pandas library. Machine learning algorithm determined 1,902 clustered cities based on offered coordinates. So we have in our million, or in our lot of offers, we cluster them in less than 2,000 cities. It's really very, very cool, but yeah, let's check our results. Let's go on with checking results. As you remember, we imported Seaborn library previously, yeah, and as SNS. object. So here we use Seaborn library. The first line, we just set style of this plot that we want to visualize, and we apply lmplot function. We pass columns that we need to render at our access, and we group them by target field that we just created by machine learning algorithm, and we use our data frame that we clustered. So, and here will be the result. So, as you can see, the result almost repeats the border of Italy, the contour of Italy map. It means that our offers are clustered all over the Italy axis of coordinates, and we have about 2,000. Actually, we have 1,902 clustered cities, and we have the same amount of colors here, which represent each city. But we don't see it for our human vision because of it is very difficult for a human vision to distinguish one color with each other. But you can see the result. It's really very cool, and we can check out these results. Really cool. So what's next? After that, we export data that we got in previous step to ML cities table in our SQL. We back our data back to SQL. It is the first step. So here I export my data back to SQL by these commands, but you can also, up to your needs, you can also save it to some CSV file or up to you. But in my case, I will export it back to ML cities table. So let's check ML cities table, the table that keeps the result of our algorithm. As you can see, we see the following. After export to SQL, we can check out our offers from Pescara and Montesilvano. Do you remember them? Our in inspecting offers, to be sure that they were clustered in one city. Technically, they should have the same target. As you can see, really, they have the same target. The offers had and still have different city ideas initially, of course, but now they both have the same target of value of 3, by which we can unite them into one city. So it's really very cool. And by these 2 lines of machine learning code, we do very difficult task. We implement really difficult task of implementation of clusterization offers into cities. And it is up to you and up to your task, up to your business task, up to your environment and programming language, what you should do with this result. Of course, I will show my approach, how to finish it, but it's up to you how you will work with it. But you can get it here that it's really very powerful tool, and we didn't code any something terrible. And yeah, it's really very cool. And let's go on. So we have this data. What do we have now? So we have cities united by target. What's next? And now let's recall that we are software engineers. Actually, we were all these steps software engineers, but we have only 2 lines of code that we were machine learning specialists, I can say. First of all, set new cluster cities for our offers. Once again, it's my example, and according to your programming language. So in my case, I just execute command to update cities. First of all, I will retrieve all prepared clustered cities that we have stored to ML cities table. You can see it here. We just retrieve the data from the database that we prepared by algorithm. Then store them to cities table with unique hash name. So we just add our prepared cities to somehow to our city table, our classical cities table. So, and we update relevant offer for this city. So we update city ID with new value, the value of the city that was prepared by machine learning. It's really simple. You can see it. So what's next? The 6th step. Get cities data. So we update offers, we clustered cities, but how get the real city data? Name, city center, coordinates, and so on. So in our database, we have the following picture. We have our inspecting offers of Pescara and Mozart Silvana, but they have updated city ID and they have the same city ID. They have the same target, and of course they have different init city ID. But it's really cool that they have this common city ID, and in city table, here at this city table, we can see that for this ID there is a row, and we have this ID, we have title that was prepared, technically was prepared by some code. It is not a real title of our place, and we don't have longitude and latitude. We don't have coordinates. So for the clustered cities we've got by target, we can easily get the city that we prepared, that the prepared cluster cities are owned to. So for example, in my case, in my decision, in my solution, I just sent to geocode API median value of our longitude and latitude coordinates of our offers. So let's imagine that we have 100 offers clustered in one city with the same target. And we just send median value. As we have a radius of 2 kilometers one to each other, for sure we will have the proper result. And yes, we can see that we send a result to Google. We pass this longitude and latitude, and we can see that we retrieve Monte Silvana city. The result will be Monte Silvana city with location, with latitude and longitude of city center. So in my case, we can use Google Geocode API. Of course, you can use another Geocode API. And we don't need, once again, we don't need to provide 100,000 or million requests. We just need to do less than 2,000 requests. So let's check once again our city table, and we can see that we update our city table with new longitude, latitude, and real title name. So for our two offers of the same target city from different suppliers, we get the mapping to Monte Silvana city. The task is solved. Just summary of it. Many of us faced with such kind of tasks that should be solved thanks to machine learning, neither using coding approach. Of course, for this example and many other examples, we can code our decision, code our solution. We should to provide a lot of analytics for it. We should to test it properly. We should to do a lot of stuff, a lot of work, and it will be very, very, in my case, in this case, it will be very expensive. And actually, this task that I'm showing now, it's really a live case in my project that I faced with several, maybe year ago or more. I faced with this project and I solved this project by this approach. In machine learning, preparing data is a very important step. For the clean, well-prepared data, we can use algorithms in the most efficient way. It is not relevant to the topic of our current discussion, but if you are not machine learning specialist, I should mention that preparing data is the most important, maybe it is the most important part in machine learning approach. So take it into consideration. It is very important to mention, just mention it. We, as software engineers, should not choose between machine learning or coding, as for me, of course. We just can enhance our skills with understanding some powerful tools of machine learning, because proper distinguishing between classical coding approach tasks and ML tasks is very important and can save a lot of time of the development. And time is money, of course, so we really save a lot of time and other things. And one more advice, maybe one recommendation is for me, as I am a software engineer, you don't need, once again, you don't need to be a machine learning specialist. The development currently is a deep ocean of numerous technologies and tasks to be solved. But as for me, you should understand the main point of presentation. You should understand when to use machine learning tasks, when to delegate our task to machine learning specialist. And the advice is very simple. It will help you to, if you don't know about machine learning, of course, consider taking one fully online course before working with machine learning. You don't need to dive deep into it. You just need to, it will be really very useful to pass one course, even without exams and so on, maybe without practice and so on, but you will understand better the situation with machine learning when you can use it, and what kind of task, the most important part, what kind of task we should delegate to it. Some credits. In my example, I use Jupyter Notebook and Pandas libraries and min shift algorithm. Of course, we can learn, we can use TensorFlow or Keras, these more powerful machine learning frameworks. But as for me, Jupyter Notebook and these libraries is more appropriate for beginners in machine learning, because they can show you the basic of machine learning, how to use it, not to lose something and not to miss something. And or even you can, when you are you even can solve even difficult tasks with such libraries, such infrastructure of Jupyter Notebook and Python libraries. So that is all. And I will appreciate some of your questions. Thank you. And that is all. I hope you heard me. The only one thing I want to say. That is all.
Thank you, Alexey. Guys, if you have any questions, please raise your hand. In the meantime, let me answer one question from a participant. That there was a question regarding the recording. If it will be available, yes, it will be. And in the handout after this session, we will provide the presentations, and we will provide the links to the YouTube published recordings. Okay, any questions, guys? There is a question from Dmitry. Do you use any big data tools as well prior to applying machine learning?
Big data, as for me, big data, I faced with such tasks, and for me, as from perspective of software engineer, I'm sometimes don't distinguish these two approaches, and sometimes use both big data or machine learning. I use, for example, Winston, as I remember, Microsoft Winston. I don't remember this the name of tool, and yes, I use such such approach. For example, when I work with selecting text from a text, I use big data approach. And usually, yes, most of the time I try to find not even implement decision for such tasks, but I mostly spend a lot of time searching for appropriate appropriate tool. But the point of this presentation, of course, it is not not about big data or machine learning or tools that we should to implement or use and so on. The topic of this presentation is to show that we need to understand when to delegate to machine learning specialist, or when to try to solve by ourselves such tasks. But yes, I faced with such with different tools, and sometimes we have very it is maybe the most difficult part sometimes is to choose the proper library or big data tool or machine learning tool for implementation. So the topic of presentation, it isn't about difference between this approach, but once again that we should I just advise to pass one machine learning course to understand the situation, to understand when to delegate. So the topic is when to delegate. And by my example, I show in my example how that it will save a lot of time. But big data, yes, I did use. but I'm not specialist at all, and all of my investigation of these approaches are based on my business tasks. So when I feel that okay, today I will, so maybe in further in future I will spend a lot of time just to invent a bicycle. So I try to find something appropriate, and I know that there are appropriate libraries that we can find.
Thank you, Alexey. A question from Vladimir. Do you know a good list of machine learning ready-to-use algorithms or tools?
Yeah, I can say I have links for it, I can say. So we have min-shift algorithm. There are also k-means, k-nearest neighborhoods algorithm. It's would be better if a person, I just can advise you to take one online course. So there are a lot of good courses for it, and it wouldn't take a lot of time to pass this course. For example, we have here, I use min-shift algorithm for it. We can use k-means algorithm, x nearest neighborhoods, k nearest neighborhoods. Also, it's up to our task, but the range of such algorithms, it's not so big. And I'm sure that almost with every algorithm that you will possibly need for solution for implementation, for implementing of your task, will be covered by passing one online course that you can take. So if I will list algorithms that I know or that I faced, it would give some interesting information. I just can say that every good course for machine learning will cover these topics, and you will understand, you will see the whole situation. If you need, in particular, exactly you need maybe this list, I can just share after. You can write me in Telegram, for example, and we will, maybe you have some kind of task that you want to solve and finding some solution. We can discuss it in chat, maybe in a few days after it. And I will appreciate it, because maybe now here, because we have online meeting, online meetup, I don't maybe get all the deep, all the sense of your, all the details of your question. And if you want, you can write. But once again, I recommend take one online course for it. That is my answer for your question.
Alexey, we have a question that might be similar to this one. Question from Dmitry. What course on general machine learning can you recommend to have this overall perspective?
Okay. Since this meetup is recording, I think it will be, I have two courses that I can really recommend, and I think they're quite good. I can recommend platforms. I can say the name of such platforms? They are different, where I took such courses. I can just once again suggest you to ask me in Telegram, and I will even send particular link to this course that I took. So if you're interested, you can write me. I will in nearest day send these courses, because I think here, I don't know, can I, of course I can say the name of this course, but I don't, it is Udemy, okay, it is Udemy platform, and it is DataCamp. I remember DataCamp platform, the two platforms where I pass such courses, and I can really recommend them. Of course, now I said say only the name of the platform, but particular courses, if you want, please contact with me. I will with appreciate share with you this link to the exact course that I took.
Dmitry, please don't hesitate and reach out to Alexey. So that's why we're here for. So one more question from Sergo. Is the using of machine learning in your problem solution is just the using of special library, or is it something more?
It depends. It really depends because I faced with different. I also used not a library. Yes, clustering. It is clusterization. It is the most easy, the most simple way for demonstration the power of machine learning. And here I am to demonstrate the power of machine learning and why it is important to understand that we can use it. I use different algorithms for it. Once again, I'm not machine learning specialist, but I use algorithms. I use even narrow networks, but for my particular tasks, and I faced with such tasks about maybe 1 or 2 times a year, and I just recall in my memory and watch once again the course, maybe online course, not every time, but it was several years ago. I used to recall memory for such course. I watched it once again just to refresh my knowledge of it. Now I more understand when to use maybe some difference. I can understand by maybe just checking the name of these algorithms. I forgot now being different forest tree and many other algorithms. I just it wouldn't be very nice if I will explain these algorithms and how they will work, because I'm not machine learning. I'm not a teacher, first of all, and moreover, I'm not a machine learning specialist. And I just want you to study with specialists and with good courses. And yes, I use such algorithms. And when I need, when I faced with such tasks, for example, I have also business task of grabbing tags from text. And for this, I use different algorithms, but I understand that for me, in my situation, that situation, the best approach was to use Winston, IBM Winston, yes, IBM Winston, as I remember, very good, very powerful tool. Also, I used it for my most of the time I solved, guys solved when we investigate this tool. We spent for proper matching, proper selecting code. It is a noun, or so just construction the relatives between different parts of the text. And I even did not code something for there. And I also used machine learning algorithms for, I don't remember, I can't say the name of the task because I don't remember here now. It is something like with grabbing a lot of parsing a lot of data, not work with. I have a lot of parsed data. It wasn't my data, but some guys have a lot of parsed data, and they just wanted to understand if there are some relatives to in real time to get the proper solution for their needs. And I just use even, it's not good, but in that case, I use several algorithms. I pass all the data. The very big advantage of machine learning algorithms that you can prepare data and then you can pass this data through many algorithms and see the results, because machine learning also provides the estimation of the checking of the results that you have. And you can see that if you have enough data, of course, you can see that, okay, it is more appropriate algorithm for my situation, or this more appropriate algorithm in my situation. And of course, it is much better when you understand what mechanical, what mathematics is under the hood. But anyway, sometimes even just passing all the data that you prepared through many algorithms can help you solve your tasks sometimes. So, but I don't recommend it to you. Just you need to understand what solutions, what instruments, what tools do you have.
Okay, there is a note from Gennady Sitnikov. About a month ago, Vladimir Borisov made a course covered basics of machine learning in grid dynamics, and there is a Slack group. This is more for, I think, grid dynamics guys. For all the external attendees, I invite you to every machine learning related dynamic talk because we have plenty of them. So there is one more question, and it's a very specific one from
Anton,
Ilya.
sorry for interrupting. One note also notice. For grid dynamics guys, there is also very good, very full covering course in Grid University, and there are links to different courses from different platforms, DataCamp and many other platforms, and you can also use, as a previous mentioned course that Anton have mentioned a minute before, you can also use this very good course, of course, in Grid Dynamics University. Sorry for interrupting, Anton. Interruption.
Sure, no worries. So the question from Ilya was, what about cities that have complex or concave borders? Will your clusterization provide incorrect results pointing to a region outside of the city?
Maybe one, not one, maybe one, maybe, okay, it will be not percent, it will be 10 or maybe 5 cities of these 2,000 cities. Google did not provide appropriate result. 5 cities to 2,000 cities, but I just do the following. I just code some. It is code. It is I coding some. If I didn't get a result, I just change a little median to median value to left or to north or east and so on. I just make some coding approach for it, and with this coding approach, usually Google works very good with this, and many geocode APIs also. It's not advertisement, but many geocoding APIs very powerful. But sometimes if you don't have a result for it, you can just for example, go to north, very small step, and check something. Then if you don't find something, go to east and so on, alongside your around your median longitude and latitude of the offers. So it is, we are still software engineers, and we should not afraid of machine learning era and so on. There are a lot of job for us to do even with machine learning. So if we have this, if we don't have results, for these 5 cities, I really solved it very easy and very simple and very quickly by this small fixing to the north, to the east, to the south, and so on. So I hope I answered your question.
Okay, I don't see any more questions. Thanks a lot, Alexey. Great talk.
Thank you, Anton.
Let me introduce